So let's take a look. So do you remember, find the largest n so that 2 to the n, what does that straight line mean? Goes into, divides into 14. What's that exclamation point? Yeah, if you, how about, yeah, so I guess rather than feeling like you need to creep out, you can legitimately leave. Feel free, and I'll help those that are planning to take the final. I could probably be more helpful to a smaller crowd as well. Aislinn. So how do we do this? How do we do for 15, 18 minutes here? I'll do what I can, and I'll stick it on YouTube, I don't know, a couple days. I'll have the rest of it up in a couple days for the finals next Wednesday. Okay, so find the largest n. So how do we do that? Remember, what you got to do is you got to break down that 14 factorial into all of its little bitty pieces. So I'm going to do it over here where there's room. 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So there's 14 factorial. So 14 all the way down. And then how do I figure out the power on n? I'm sorry, the n power on 2 that'll make that work. How do I do that? Anybody remember? Find the stuff in them. Yeah, the primes, right. Prime factors, exactly. Yeah, basically I'm looking for how many 2's are in there, right? Because this is 2 to some big power. Like I'm trying, maybe it's going to be 2 to the 9th or 2 to the 12th or whatever it is. It's going to be some big power on a 2, which means it's going to be a bunch of 2's, huh? So I'm really trying to figure out how many 2's go into 14 factorial. How many 2's does it have? So let's take a look. In 14 is 2 times 7. There's 1 2. 13 doesn't have any 2's. 12 is 4 times 3, and 4 is 2 times 2. There's 2 more 2's. You with me so far? I've got 3 2's already. Let's go to the 10. The 10 is 2 times 5. There's another 2. Notice I'm skipping the odd numbers. They don't have any 2's. Now go on to the 8. Look at the 8. 2 times 4, and 4 is 2 times 2. There's 3 2's. Keep moving. Let's go on to the 6. 2 times 3, there's another 2. Go on to the 4. 2 times 2, and then don't forget about the 2 itself. All right, what's the total? So I got to count all those up, don't I? 1, 2, 3, 4. Don't miss any. 5, 6, 7, 8, 9, 10, 11. So n's 11. You can 2 to the 11th is the biggest power it's the largest n. It's the largest power you could put on there and have it go in, have it divide in. If you did a 12th power, 2 to the 12th would not go in because there's not 12 2's in there. There's 11 2's. So you could do 11 or any number less than that and it would go in. 11 is the largest number. Does that make sense? What we're doing there? Okay, and then B is harder. Questions so far? Now we got to do B. Can you do B? Let me give you a second. Well, here, can I move to a fresh screen? You got that copied down? You good to there? So when you start doing B, remember that 6 is made out of 2 times 3. So you're really trying to find out how many 2's and how many 3's go into 20 factorial, right? So let me get a fresh screen for that. So 6 to the n, this is 1b, b. 6 to the n dividing into 20 factorial. So if I break down this, so I'm going to go 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay? And we're looking for how many 2's and 3's. Because whenever a 2 and a 3 get together, they make a 6, don't they? So it's basically finding out how many 2's and 3's over here and all that stuff. Break all those numbers down. Find out all the 2's and 3's and then put them together. Find out how many times 2's and 3's get together to make 6. And that's how many 6's can go in. But hold on a minute. Do you think there's going to be, I want to do this in the easiest way. That sounds like a lot of work, right? I want to do this in the easiest way possible. What do you think there's going to be less of? Is there going to be less 2s or less 3s? There's going to be way less 3s, because 3s only happen every third number. 2s happen every other number. There's going to be less 3s. So let's just find out how many 3s. And that'll tell us how many 2-3 combos get together. Does that make sense? I think I called it like a junior high dance when we did this problem back in the first unit of the course. Right? The boys and the girls at the junior high dance. If there's only 10 girls and there's 100 boys, there's only going to be 10 people, 10 couples dancing, right? You're limited by what there's less of. Right? So we want to find out how many 2-3 couples dance here. All we got to do is find out how many 3s, because there's less of those. So how many 3s? Well, 18 has, 3 doesn't go into 20 or 19, so I skip them. But 3 goes into 18, right? Let's break 18 down. What is it? 2 times 9, 3 times 3. There's 2 3s. They were hiding in the 18, right? Let's keep going. Does 3 go into 17 evenly? No. 3 go into 16 evenly? No. 15, yeah. Let's break it down. What's in 15? 3 times 5. There's another 3. See how it's going to be every third number? 3 doesn't go into 14 evenly. 3 doesn't go into 13 evenly. But 12, yeah. 3 times 4, there's another 3. See, it's every third number. 3 goes into it. 11, 10, no. 3 doesn't go into those evenly. 9, yeah. 3 times 3, there's 2 3s in 9. 8, 3 doesn't go into 8 evenly. 3 doesn't go into 7 evenly. 3 goes into 6. 2 times 3, yeah. Oh, I circled the wrong one. 2 times 3, the 3, and then the 3 itself. So how many total 3s do we end up with over there? 1, 2, 3, 4, 5, 6, 7, 8 3s, and plenty of 2s. So how many couples are going to dance? 8, 2, 3, which is 6 combos. Right? Because we're limited by 3. So there's 8. So the biggest power you could put on that is 8 and have it go in. 6 to the 8th power will go into 20 factorial. But 6 to the 9th will not. Because there's not 9 3s over there. There's only 8 3s. Good for doing those. This is on the non-calculator part. So you can just break it down by hand like that real quick. Is that good? Questions I can answer on that? Remember that? You remember me talking about the junior high dance, right? My analogies work for you, I hope, a little, maybe? All right, let's try number 2. All right, 3 2/5. Change to a percentage. This is again, this is the last question. It's only going to be 2 questions that are without a calculator. The rest of the whole exam is with a calculator. So how do you change 3 2/5 to a percentage? Let me give you a second. Try cranking through some of that. Let me jump in. So 3 2/5. How do you do this without a calculator? Well, I would suggest, do you know how to turn a fraction into a decimal? Like how do you, let's just take the 2/5. We know what the 3 is. The 3 is just 3. But how do we take like 2/5 and make that a decimal? Let's first make it a decimal. Then it'll be easy to turn it into a percentage from there. How do you make a fraction into a decimal? Does anybody know? You can long divide. Bottom into top. So 5 into 2. So 5 into 2. And if I was you, I'd be thinking 5 doesn't go into 2. What do you mean 5 into 2? Right. Okay, that's a good point. So what we do, anybody remember? What do you do? Because 5 doesn't go into 2.
Add a 0.
Yeah. Now I don't just add a 0, huh? What else do I add? Yeah, because that would change. If I just put a 0, that'd be 20, and that's a different problem. But if I put a decimal, then it's 2.0. It's the same as it always was. It just looks different, huh? 2.0 is the same as 2. And now we can do it. Exactly. Remember that? You just make it, just add 0.0. So 5 goes into 20 4 times. Remember, now, it's important where you put the 4. Do I put the 4 there? No. How do you know where to put the 4 when you're doing like long division with decimals?
The last number.
Yeah, it has to go over the last number of what you're going into. I'm going into 20, so it has to be over the 0. The lineups really matter, son, when the decimals. So that'd be 20, remainder 0. Decimal goes straight up, as you know. So 0.4. So 2/5 is the same as 0.4 decimal. Okay, so what? Well, that means 3 2/5 is the same as 3.4 decimal. So our answer is 3.4. No, not quite. Not quite. That's decimal, but now we got to change to percentage. The final step, you've got to actually make it a percentage. This is where some people get tricked, I've noticed. So remember, if that's there, it's not just a decoration, right? It changes things. It isn't, it's not just a looks thing. It actually has an impact. So what do? When you put a percentage symbol on a decimal number, what happens to it? It's like a magnet. Pulls it 2 places to the right. That's why there's 2 zeros in the percentage symbol, huh? It's reminding you 2 places. So the answer is actually 340%. Did that make sense? So I first made it a decimal by long dividing bottom to the top. And once I have a decimal, when you put the percentage on there, it pulls it 2 places to the right. That's what the 2 zeros remind you. Now, if you take off a percentage, that's when it goes back 2 places. We'll do those in a minute. All right, so can you try B then? So on B, can you long divide? Do the same thing. This is without a calculator. This would be the non-calculator part. Can you do B? Bottom into top, long divide, get a decimal, then put the percentage on there, move it 2 places to the right. It's like a magnet. So I'll do B here. So 8 into 3.0, right? Goes in there, what's that, 3 times? 6, and then you add a 0, and bring it down. Keep going. Decimal goes straight up. 8 into 60, 7 times. 4, add a 0, bring it down. 8 into 40, 5 times. Do you remember all those times tables? It's easy to get rusty on those when we use the calculators all the time, huh? So 0.375. I was working with my son the other day. He's 15. He's doing some trigonometry class, and he was doing like 7 times 8 or something like that. And he was just reaching for that calculator constantly. I'm like, Johnny boy, tell me 7 times 8, please. And he's like, he just started guessing numbers. I'm like, okay. I'm gonna mention to Mom that you need to be doing some flashcards. You can't be wanting to become an engineer when you don't know what 7 times 8 is. But I know it's easy to forget if you use calculators all the time. So 0.375, and then you put a percentage on there, and zoop, zoop, 2 places to the right, right? 37.5%. Good on that? It's making sense? And so C is the same way. I'll do that one. 5 into 4. Make it 4.0. Goes in there 8 times. So if you do forget, if you are rusty, it's fine for you. You don't want to be an engineer, I'm assuming. It's not fine for my Johnny boy if he wants to be an engineer. He needs to know his times tables. But if you're rusty on them, it's fine. Just add on the side real quick. You know what you could do? Like if you're just like in the middle of the final and you're just like, I don't remember, 7 times 8. Just add up a bunch of 8s. You know what I mean? Just add up 7 8s. If you're rusty. Make sure you're right. Don't just do what Johnny did and guess. That's not a good. It's scary. He wants to build bridges one day. So don't just guess. He needs a little more training. So don't just guess. Make sure you're right. Add them up. So, all right. So it goes in there. 5 times 8 is 40. 0.8. So it's 0.8. But then the percentage. Boom, boom. 2 places to the right. Boom, boom. It's going to be 80%. The decimal one's up here. You don't have to put the decimal. You can leave it off. Same thing either way. 80%. How about D? Okay, and D, I'll do D down here. So the bottom into the top, 200 into 13, make it, and it doesn't even go into 13.0. I'm going to have to add 2 zeros, huh? Because 200 doesn't go into 130, I have to add 2 zeros. So how many times does that go in? Like 6? And where am I going to put the 6? This really is important here on the lineup. Y'all seeing the lineup here? Here, put in lines. That might help. I think that's a good thing to teach kids to do, is to put lines down just to keep it really lined up. So it's going to go in there 6 times, right? 6 times 0, 6 times 0, 2 times 6 is 12. That good? Subtract 100. And that means it's 0.06 so far. Now, 200 doesn't go into 100. What am I going to do? Add a, not there. Add a 0. Right, bring it down. So 200 goes into 1,000. 5 times, huh? 0, 0, 10. Perfect. 0.065. So this is 0.065. But the percentage, 2 places, 6.5%. Huh? Does that make sense? Feel like you could do those okay? Just long divide and move it 2 places. And you know what? I should say this. You get a full sheet of notes for the final. Not just a 3x5 card. Put anything you want, full, regular size paper, 8.5 by 11, normal paper. Put anything you want. So you can write, if this feel like you're not sure about this, write 2 or 3 of these exact problems down with all the steps and everything. Do whatever you want. Both sides of a full sheet of paper. So I'm not into you memorizing a bunch of math stuff, probably because I have a terrible memory. I'm just into you knowing how to do steps. So we're about the steps, not memory. So write down whatever you need. If you need one of these examples, write it down. If you need a little times table chart, that's fine with me. Print it out and put it on your, if you think I'm a little rusty on the 7 times 8, we'll put a 1 through 10 times table. That's fine. Anything you want, both sides of a full sheet of paper for the final. Okay, we just have moments left. How about E and F? Let's do those. E, 5 3/4, changed to decimal. So it is a percentage right now. So you notice these start with percentages, the other ones ended. So it is a percentage. So here's what I would do as we run out of time here. What is 3/4 of a dollar? 75 cents, huh? So this is I would just do that real quick. That's 5.75. You know that, huh? Percent. But now they want me to take off the percent. See how there's no percent over here? I'm changing to a decimal. So what happens when you get rid of the percent? When you get rid of it, it goes back 2 places. Just the opposite, huh? It was a magnet holding it there, so it goes back 0.057. That's a 5 there. So it'd be 0.0575. And the other two are the same thing. Just get rid of the percentage after you make it a decimal.